Assalamu alaikum warahmatullahi wabarakatuh. Sat Sri Akal, Namaste, and good afternoon to everyone who is watching this free for all mathematics class and who are following since day one and attending all these lessons one by one every week. As you know, that today the topic of my this lesson is that determining the point of intersection in the linear equation system. So in linear equation system, how we can determine the point of intersection or something which in other way we can call the solution of those linear equations when you are giving two linear equation in the same scenarios, and you can find out their point of intersection. Always remember, when that point of intersection is being the coordinates of that point of intersection are being utilized or being inserted in that equation, your equation will give same value. That shows that both those the actual number or one point is, or sometime in particularly you can say those that point of intersection is actually the solution of that linear equation system. I'll give you an example that how we can identify that which point is actually the point of intersection if there are two linear equations and if they are going to have a common intersection point or not. Remember, the linear equations are basically straight line equations, and if those straight line equations are not parallel to each other, then some point somewhere they are going to intersect. That's for sure. If those two lines are not parallel to each other, means their slope can identify whether they are parallel or not. But if they are not parallel, means they are going to intersect at any point. It might be very close area or might be very far spot. So somewhat they are going to intersect. So I can give you an example which I'm using from this book. I have a graph drawn for two linear equations between the time used and the cost. And the example I am using is, which I'm going to just explain, that a linear system contains two or more linear equations representing different conditions for the same context. The two equations are graphed on the same coordinate plane. Two lines that are not parallel will eventually intersect at one point. The point of intersection occurs where the two lines have the same y values. It is also called the solution when the values are put into a system of equation. As I mentioned, you will get the same result. And if they are intersecting, that intersecting point, if you insert into that equation, will give you the same value. Then point before and beyond the point of intersection can provide the information about the differences in the condition of a given realistic situation. So I'm utilizing an example given here is that a cell phone company offer two different plans. Plan A is that $20 basic price per month and then 10 cent per minute additional minutes. The plan B is $30 per month, and then you have a 5 cent per minute for the additional minutes used. Now, how many minutes per month would a person need to talk in order for plan B to be better option? So this is how we are going to calculate. And the equation we have derived from here is, I'm going to write down here that let's say the equation is, we have a plan A, as I said, $20. That was the basic to start with. And then each additional was 10 cent per minute. The second plan B was starting dollar is 30 plus 0.05 cents per minute. So now how we are going to calculate in this particular situation, if you see the point of intersection represents where the monthly cost of the plan is the same. So what I did, this is the plan, I should write down here that that was the plan A. This is plan A and this is plan B. So in plan A, as we see, the $20 is the starting, and then we have a $20 starting point. From $20, keep increasing, and then it line straightly goes to this point. For the plan B, starting from $30, and it has a less cents per minute cost for the additional minutes. The plan B is bringing to all the way this point. So when you draw the actual graph, you will notice that right at this spot, these are intersecting each other. So these are intersecting each other, but now if you see in this, the cost is increasing, keep increasing up. So if this line goes right here. But in plan B, after 200 minutes usage, it goes this way. And now you can see the plan B is going to be more effective for someone who is going to use regularly 200 or more minutes, because after 200 more minutes, this was the point of intersection. This plan is going to be expensive and plan B is going to be less expensive. So this is how you can identify in any linear equation systems that which, first of all, the point we are discussing today is their point of intersection. So in this, we have a plan A, which was represented by this equation, which is a linear equation of a straight line. We have a plan B, which was represented by this equation, which is a linear equation, and we utilize different numbers, and this is how we got this line. For observing this line, we find out that both lines are actually intersecting right at this spot. And right at this spot means if I intersect like this tells you that. So this whole thing, this piece of graph shows you that this is the spot where both plans intersect, means their value remains same. At this point, when somebody is using plan A or plan B and they are using 200 minutes, their billing is going to be same. But after 200 minutes, plan B is going to be more effective, more cost effective or cost savings in plan B if you are utilizing more than 200 minutes. So this is how we can utilize in the daily life examples that in two linear equations, if they are not parallel, remember this key point, if they are not parallel, they are going to intersect at some point no matter what. In this particular equation, because they were not parallel, they are intersecting at this point. And then because we were just discussing a daily life example from the cell phone bills, now we can say that someone who is going to use regularly more than 200 minutes should be using plan B, because plan B after 200 minutes will be cheaper. And if somebody knows that they are not going to cross the 200 minutes, this plan is always cheaper for them. So this is from a daily life example. The two linear equations will intersect at a point, and how we identify this is the different ways I have explained. I hope that I was able to explain the difference, how we determine the point of intersection in two linear equations. Remember, two linear equations which will be, which are not parallel to each other will intersect at some point, and we need to find out the point of intersection. There are different ways. So after this topic, I like to mention that we have covered our most of the syllabus. The last chapter, which I have left, which I'm going to start next week, is going to be our, let me see, the topic name was measurements and geometry. So the next topic and the last topic for grade 9 would be this measurements and the geometry. And after this topic, our grade 9 lessons will be done and we'll be moving on to grade 10 lessons. And again, I am numbering each and every week lesson with a serial number. If you are just a beginner and just join me in these sessions, please do not hesitate, scroll back and watch for my lesson 1 and then lesson 2. And I always share, this is the mathematics book grade 9, which I'm using. After this is finished, a few weeks more, then I'll be moving to grade 10 book. You can buy this book and then follow these, those lesson by lesson 1, 2, 3. Today, I exactly don't remember. I'm going to post the number as soon as I go back and save this Facebook live video on my Facebook page. I'll definitely assign a number. You can go and watch lesson by lesson each number and follow this book. I'm confident you will be good to go for grade 9 and you will have all what you need for grade 9 mathematics. But still, if you have any challenges, do not hesitate. Contact me at 416-571-1163 through Messenger, through WhatsApp, and I'll be more than happy to assist the families and friends around here who needs any help in mathematics. Mathematics is my passion, and I love to teach. And I have started this during this pandemic time, and I'll continue as long as I can to help these local communities. And by Facebook, I think I might be able to help beyond the local communities and whoever can watch this program live. So thanks and enjoy your wonderful Sunday.